The solar system looks simple on a classroom poster. The sun in the center, planets lined up around it. And if you want to visit one, you just go there. So you might think the rule is obvious. The farther the planet, the longer the trip. But the real solar system does not work like that. In fact, the closest planet to Earth can take years to reach. Not months, years. And the reason has almost nothing to do with distance. Because space travel is not about crossing empty space. It's about surviving a machine made of gravity, motion, and timing. First, we have to fix the biggest misconception about traveling through space. You don't drive through it. There are no straight roads between planets. Every planet is moving. Earth is moving. Your spacecraft is moving. Which means the moment you launch, your target is already somewhere else. So a spacecraft doesn't aim for where a planet is. It aims for where that planet will be. It's less like driving to a city and more like jumping from one moving train to another moving train, while both are circling the sun at tens of thousands of kilometers per hour. And once you understand that, the solar system stops looking like a map. It starts looking like a giant moving machine. Nowhere does this break intuition faster than Mercury. Mercury is the closest planet to the Sunday, and depending on the alignment of the planets, it can be closer to Earth than Mars. So it should be one of the fastest places to reach. Right? Wrong. Mercury is one of the hardest planets in the solar system to actually arrive at, because going closer to the sun does something dangerous. It makes you faster. A spacecraft falling inward toward the sun accelerates dramatically. By the time it reaches Mercury's orbit, it's moving so quickly that it would simply blast past the planet. So the real challenge isn't getting there. It's slowing down enough not to miss it. The European-Japanese mission Bepi Colombo had to perform a complicated series of gravity assists around Earth, Venus, and Mercury itself just to bleed off enough speed to enter orbit. The journey takes years, all to reach the planet that looks almost next door on a diagram. In the real solar system, closer does not mean easier. Now compare that to Venus. Venus is our closest planetary neighbor, and in terms of travel time, it's actually the easiest planet to reach. A favorable trajectory can take only a few months. For spacecraft, Venus is a relatively quick trip, but arrival is where the problem begins. Because Venus is one of the most hostile places in the solar system. Surface temperatures hot enough to melt lead. Atmospheric pressure more than 90 times Earth's. So Venus creates a strange contradiction. It's one of the fastest planets to reach, and one of the worst places to actually stay. A quick trip, a terrible destination. Then comes the planet humanity cares about the most. Mars. On paper, Mars doesn't seem that far away. Robotic missions typically take around 6 to 9 months to reach it. But the flight there is only the beginning of the problem, because Mars introduces something new: waiting. Earth and Mars orbit the Sun at different speeds, which means the window for an efficient return trip only opens every 26 months. So, if astronauts travel to Mars, they cannot just turn around and come home. They have to stay there, often for around 500 days, waiting for the solar system to line up again, which means a realistic human Mars mission isn't a short expedition. It's a commitment measured in years. The flight out, the long wait, and the flight back. Mars isn't just a journey, it's a chapter of your life. And everything up to this point is still happening in what we call the inner solar system. Once you move beyond Mars, the scale changes dramatically, because now we reach the giant planets. And these worlds are so far away that spacecraft often need help just to get there. This is where gravity assists come in. Instead of burning huge amounts of fuel, a spacecraft flies close to a planet and steals a tiny bit of its orbital energy, like a slingshot. It's an elegant trick, but it's also a kind of admission. Because when missions rely on gravity assists, it means brute force alone wasn't enough. The spacecraft needs the solar system itself to help throw it forward. Take Jupiter, the largest planet in our solar system. Some missions have flown past Jupiter relatively quickly. NASA's New Horizons probe reached it in about 13 months. But that was just a flyby. It didn't stay. And that difference matters. Flying past a planet is one thing. Entering orbit around it is something completely different. NASA's Juno spacecraft took about 5 years to reach Jupiter before it could begin studying the planet up close. Because slowing down and settling into orbit requires enormous energy. A flyby is like speeding past a city on the highway. An orbital mission is like moving there. Beyond Jupiter lies Saturn, the ringed giant. And by the time you reach Saturn, the travel time starts to feel heavy. NASA's Cassini spacecraft launched in 1997, and it didn't arrive at Saturn until 2004. Nearly 7 years of travel, long enough for entire chapters of life on Earth to change, while the spacecraft was still cruising through space. Saturn marks a kind of threshold. Beyond this point, the solar system begins to feel less like a place we visit, and more like a place we send machines. Because beyond Saturn lie the ice giants, Uranus and Neptune. These worlds are so distant that humanity has only visited them once. Both were explored by the same spacecraft, Voyager 2. Voyager 2 reached Uranus in 1986, and Neptune in 1989. After traveling billions of kilometers through space, decades later, no spacecraft has returned. Because missions to these worlds are not just long, they're generational. Even with modern technology, a spacecraft traveling to Uranus might take close to a decade to arrive. Neptune can take even longer. By the time you reach the outer edge of the solar system, mission timelines start competing with human life stages. These are not short trips. They are life chapters, which reveals something surprising about our solar system. We talk about the planets like they are neighboring worlds, places we might casually visit one day. But mission reality tells a different story. Each planet is its own physics problem. Mercury forces you to slow down against the pull of the Sunday. Venus welcomes you quickly, then crushes anything that lands. Mars traps you in orbital timing windows. The giant planets demand gravity, assists just to arrive. And the ice giants stretch missions across decades. So the next time you see the solar system drawn neatly on a poster, remember something. That picture is small, clean, simpler, but the real solar system is none of those things. It's a vast, moving machine of gravity and motion, and reaching another world inside it is far harder than simply crossing the distance.